Welcome, everyone. Good evening. I'm Janelle Gurley, Director of Science and Programs at Environmental Association, and it is an earnest pleasure to welcome back Dr. Richard Blundell with us this evening to present why science matters and share his thoughts with us this evening. And before we begin, I would like to thank Bank of America, our lead sponsor, as well as our alternate sponsor, Cisco Brewers of Nantucket and the White Elephant Hotels and Resorts of Nantucket and Palm Beach. It is without further ado that I quickly turn everyone over to Dr. Blundell after a brief bio to introduce him very quickly. Dr. Blundell is a scientist, an adventurer, a philosopher, and a surfer. He has developed Oika as a living philosophy that draws on deep ecological principles and cosmic evolution to be a source of wisdom for our time. Without further ado, Dr. Richard Blundell. Welcome. How are you?
Good. Thank you, Janelle. Sorry for that mouthful. That's my new bio. So you kind of surprised me with that one, but well done. Thank you. It's great to be here.
We are blessed to have you.
Thank you. Great. So I guess I just want to jump right into it. How do I get back to my
You start sharing again.
Okay.
You'll trump me in that area.
Okay. Okay. Where'd it go though? For some reason it's not about. Stand by. Are you seeing that now? Why science matters?
Yes, sir.
Okay. Great. So yeah, I just wanted to start off again. Thank you, and I want to start off by saying that this isn't really going to be, a highly technical or hardcore science lecture, as the name suggests. It's going to be more about why an exploration of why science matters, and especially it's an exploration of how science matters to me personally, how I've developed a tendency to derive meaning and value out of science. But I don't want it to, and just so we know what we're looking at here, this is it. This is really in I was going to say in a nutshell, but more really in a spiral shell shape. This is really it. This is where I go for what matters. This is a depiction of the story of the entire story of the universe. And we're going to get into this later, but I just wanted to show it to you just to sort of introduce it, because this is going to be where we're going to spend the evening in this story of the cosmos. But I also don't want this to be, a kind of self-indulgent exercise in how I see science and how I derive meaning from science. So I wanted to take a moment first to really frame this question of why science matters in the predicament, in the circumstances of our time, which are the word that comes to mind is dire. That we are living in a time of profound change, and I think it's important that we seek sources of wisdom and meaning in addition to just knowledge. And so that's what I'd like to spend a few minutes doing, is a kind of deep dive into what I mean by mattering when I say why science matters, and explore that a little bit first to set the context. And again, it's the context of our current situation, which we can get a sense for what our situation is by flipping through this report, which is a report of the global risks of 2023, some of these existential risks that face humanity in our time. And one of the pages that stood out to me was this one. It's kind of a topological map of some of the big problems. I don't expect you to really see this or be able to read it or make all the connections. But what this is, it's kind of explosion in a spaghetti factory of big, complex, intractable problems all interacting with each other in a way that creates the crisis that we're in. And I find it, everything from environmental problems to economic and to social and technological problems that are all depicted on this graphic. When I was doing my PhD in big history, the frame that I used to describe this intractable situation was the wicked problem. And then I actually discovered a higher degree of wicked problems called the super wicked problems. And this is kind of what describes the current situation. We're in a super wicked problem. And one thing that I find interesting, though, in this graphic is the big thing that's missing that you may have heard about lately, and that's this: artificial intelligence. It's not even on this graphic. And I don't know if anyone here is paying attention to recent developments. I'm sure you've probably all heard of ChatGPT and large language models and that sort of thing. But if you are listening, you will be hearing a lot of really intelligent people, very much in positions of authority and power and privilege, saying pretty profoundly terrifying things about what could happen in the face of this new technological advancement. It's hard to get your head around the possible scenarios through which this new technology could play out. It really puts things at risk. It puts things into existential risk, in fact. And so I wanted to add this to the list of things that matter, and that I think that an understanding of science in the way that I'm going to present it tonight could help us to make sense of this map, and especially this AI element. There is a word for this, another word for this, so we don't have to be calling it super wicked problems. They call it the meta crisis. So let's take a little look at what people mean by this idea of a meta crisis. This is a guy who's a monk and a podcaster, and he says, the meta crisis is the multiple overlapping and interconnected global crises that our nascent planetary culture faces. It's a pretty good, succinct description of what we're facing. Here's one that's a little bit more in depth. We may be thinking of it as an ecological crisis. We may be thinking of it as a psychological or spiritual crisis. We may be thinking of it as a cultural crisis and a breakdown of community, family, etc. We may be thinking of it as a crisis of government and economics and finance. And it is all of these things, but it's not reducible to any of them. That's why it's a meta crisis. This is Terry Patton, who's a technologist. Okay, and we could get even deeper. I know these are long, but bear with me. This is Zach Stein, an educational philosopher, saying there are the ecological, economic, immigration, geopolitical, and energy crises, but there is also an invisible crisis unfolding within our own minds and cultures that is getting much less attention. This is the meta crisis, which has to do with how humans understand themselves and the world. It is a generalized educational crisis involving a set of related psychological dynamics. Systems and societies are in trouble, but it is the psyche, the human dimension, that it is in the direst of straits. So you're starting to get a sense for like the true complexity of this, and the breadth and the depth to which this crisis reaches. And here's another one. And this is from a friend and someone that I've had some good conversations with, John Vervaeke. He's a cognitive scientist, so get ready for this. He says, we're in a meaning crisis. I think this pretty much sums it up. It's very simple. It's succinct. It's saying we've lost our capacity or sources of meaning. And this is really where I want to go with this, with this idea of why science can matter. I think it can matter precisely in this dimension of the meaning of the meta crisis. How can we derive meaning from science? This is one way that science matters. So before we go a little further, I just want to make a little bit of a distinction between what between knowledge and meaning, because I am talking about science, and science is typically associated with knowledge. We use science as a way to generate knowledge. And because I'm going to be talking about meaning, I think it's worthwhile to stop and just sort of do a quick analysis of what the difference between knowledge and meaning. And to do that, I want to first make a distinction between knowledge and wisdom. And for that, I want to start here. Knowledge is knowing that a tomato is a fruit. And so here's some scientific descriptions. Wisdom is knowing not to put it in a fruit salad. So I think that kind of captures the essence of what we're talking about here. Knowledge we get. We can take things apart. We can put them into diagrams. We can explain things. We can see how the parts fit together. But that doesn't capture the essence of what a tomato would taste like in this. You just don't do that. The Italians know this when you just don't put it to, it's like putting garlic on peanut butter. Doesn't do it. So it's a little bit ambiguous, and science isn't comfortable with ambiguity. The whole point of science is to kind of take away the ambiguity. And so that's why there's tension in this conversation. But I think we need to soldier through the tension and see if we can't still work toward meaning. So I'm going to continue this line of investigation to explore a little bit more about the meaning of meaning. What does it mean? So here's a good description. The meaning is the web of connections, understandings, and interpretations that help us comprehend our experience and formulate plans, directing our energies to the achievements of our desired futures. Meaning provides us with the sense that our lives matter. That's pretty good. I can live with that and keep that. I can hold that as I explore the science of cosmic evolution. To go further about the value of meaning. So this is going to be my quick and dirty science of meaning slide. So what we're going to do, I've seen this a meta-analysis of all the different ways in which this concept of meaning brings value to people. So there's been all these studies that they did where they ask people, how does and not just ask people, but they've done, quantitative studies about how meaning serves people in life. And here's some of the quantitative, published results of meaning in life studies. Meaning in life predicts a higher quality of life, higher life satisfaction, a state of general health, higher occupational adjustment, lower incidence of psychological disorders. Meaning in life predicts lower suicidal ideation. It predicts more social appeal. It is related to slower age-related cognitive decline and lower risk for Alzheimer's disease. It predicts a decreased mortality, which is kind of a general way of saying it keeps you alive longer. And it even lowers the risk of heart attack. So there's a scientifically validated literature on the value of meaning in life, okay? But that's not really what I'm talking about. In any case, moving on, here's a quote for you. We're not exactly sure where meaning comes from, if it is inherent, or if it is real at all. What we do know is that humans flourish when they have it and suffer when they don't. I like that. That works too. I can use that. The point here is that meaning is important, and if we don't have it, we suffer. So let's just sum up this. These are some of the things that I think about when I try to define meaning. I believe that meaning includes an inner dimension. In other words, that it's knowledge that has some relevance to me. That's one thing that makes knowledge meaningful. So in other words, meaning has an identity component. I'm laying these out because I'm going to be telling the story of the universe in a little while, and I want these ideas to be with us as we walk through that story. So it has an identity component. There's something in the science I can identify with. And also that meaning has a narrative dimension to it. There's lots of research out there, and there's a lot of evidence just in culture that we're very much a storytelling species. Narrative is at the heart of how we make sense of the world. It's how we derive meaning. It's how we make meaning. It's central to how human beings function. And so it makes sense then that any meaning that we're going to derive has got some narrative component or narrative dimension to it. So what are some of the different sources of meaning? Obviously, lots of people derive meaning from religion. And there are myths that also account for a lot of meaning, whether it's identified or not in our culture. History is a huge source of meaning for people. National and ethnic identities generate and maintain meaning for people. Spiritual traditions are a huge source of meaning. I work with a lot of philosophers, and I see them deriving an incredible amount of meaning from their philosophical commitments. But then there's science. Science, by its very nature, is not supposed to be a source of meaning. Science is, the whole point of science is to remove meaning from its pursuit. It's to say, I'm going to look at the world objectively. I'm going to remove any preconceived notions of meaning, preconceived values, preconceived biases. I'm going to try and remove those from the pursuit so that I can get to the truth. And as a scientist, I totally appreciate and can try to honor that commitment. But I do think that we're throwing out the baby with the bathwater in some sense. That's not to say that I don't want to do good science, or I don't think that the scientific method is valid. I do. I just think that we need to develop ways of, or at least comfort with, being able to derive meaning from scientific knowledge. That's the point here. So now I want to get back to this. Again, this is the story of the cosmos in a spiral. Just briefly, you can see in the middle there's a little white dot that's supposed to represent the Big Bang. And then this story unfolds in a counterclockwise direction out from there. And it unfolds through the early physics of the universe into, early celestial and stellar dynamics. And then you can really start to see galaxies and stars and how they form. And then down toward the bottom there in the middle, you see an orange thing. That's the sun. And then that's actually the protoplanetary disk. We're going to stop there. And then you can see the Earth and the moon crashing into the Earth. And then you can really start to see the history of life on Earth. It turns blue. And then there's all kinds of mountain building events and glaciation events. And as it comes around down through the bottom, life really kicks in. You can see the Cambrian explosion down there toward the bottom, and then up toward the right, colonization of the land, and you see the diversification of life. You can even see that big yellow thing in there in the middle. That's the asteroid that took out the dinosaurs 65 million years ago. Diversification of mammals, hominids, on up to, and then you can just barely see this little gray area in that top right corner of a city. So that represents sort of civilization. So this is it. This is the whole story of the universe. And what I'd like to do on this is, you watch this. I've created a narrative, a through line that will trace this story, and I've mapped out 1, 2, 3, 4, 5 stops along the way. And what we're going to try to do is see if we can derive meaning from these 5 stops. I could have picked a lot of other stops. I mean, this is an incredibly rich story. There's so much detail and there's a lot of science in this diagram. We could have stopped anywhere, but I've picked 5 just almost at random, but I think that they represent moments in the history of the universe where there happens to be a particularly rich source of meaning to be had. So that's what we're going to do. We're going to start at the Big Bang, work our way through, stop at each one of these places. I'm not going to go deep into the science, but I'm going to try and give just enough so that we might be able to derive some meaning from that. All right. Oh, so before we go, I just want to keep these points in mind. What we're going to be looking for as we do this is coherence. We're trying to see how all these things string together. in a coherent way. We're looking for connections, things that can connect the things that we're talking about to each other and to us. So connecting us to the world and each other. We're going to see if there's any purpose. In other words, we're looking for instances of causal continuity, when one thing causes another and causes another and causes another, and eventually it comes to cause us. That's called purpose. See if there's any significance. See if there's anything that feels gratifying in the process. Look for instances of things of relevance that we feel to ourselves. And here's a really important one, to see if we can't find instances where something pops out that really reveals that we have a shared legacy and fate. Okay, meaning of meaning. Sorry, one more. Again, we've already done the science of meaning. So from now on, we're not doing the science of meaning. I'm not talking about the science of meaning. I'm talking about the meaning of science. So we begin. We start in the Big Bang, and we're going to go to stop number 1. I usually start this whole story in a place called mystery. For reasons that are hard to understand, there's actually built-in checks on how much we can know, the resolution by which we can know things. And because of that check, because of that sort of that limit on what we can know, there's a mystery that's built into the universe. I like to acknowledge it because it keeps me humble. But then we have this event, usually referred to as the Big Bang, when there was this rapid inflationary period, and the universal forces of the universe got themselves sorted out, and things started to happen from there. We've got a pretty good picture of the cosmos that we've been able to compose. And what this is, it's an image, it's just a graphic of the entire sort of spatial representation of the universe, looking at the Big Bang on the left, which is that bright thing, and then the period of inflation, and then you see this bright disk. So what we're looking at here is, imagine being that satellite on the right there, and I'm going to tell you about that in a second, and looking to the left, and you're looking down this funnel through all of space, and you're looking back through all of those different stars and globular clusters and galaxies, and then eventually you get to this clear place where there's the dark ages before the first stars formed, and then eventually you hit this disk of blue light that you can see there. That's what we're going to be looking at next. That's called the cosmic microwave background radiation. That's the first stop on this tour of meaning making through the universe. So what are we looking at? I think it's helpful to understand what we're looking at. It's really helpful to understand how we took this picture. This is a picture of some of the cosmic microwave background radiation, and this next little graphic is going to show you how we took that picture. So this is a satellite. It's called the Planck satellite. It sees the world in the microwave band. So it doesn't look in visible light. It looks in microwave light. We sent it up into orbit, and it spins. So it's out there spinning around, and it's taking these pictures, this sort of continuous picture of space. You take that picture that it's taken, this spherical picture, put it flat, it looks like an oval. Then you start to remove all the different sources of, errant light, errant radio signals and things like that. And as you do that, you peel away all those different things, and you correct for all the different mistakes, and you find that image. So the way to think about this is that if you were standing on the surface of the Earth and you could look out with your eyes tuned into microwave band of light, this is what you would see. You'd see this background behind everything of this early light of the universe, which is seen in the microwave from here on Earth. That's what we're looking at right there. So what is the meaning? Like, the idea here is, this is all science, it's basically a picture of the minute differences in temperature of the early universe. This is about 380,000 years after the Big Bang. So it's a very, very early picture. It's a baby picture of the earliest light of the universe. But what we now know is that this light evolved into everything that is. So if you look around the room that you're in right now, all the things that are in it evolved from this light and this this energy and this matter, this hydrogen and helium, under the forces, the universal forces of gravity and electromagnetism and nuclear forces, come together in certain ways to create stars. Those stars create atoms. Atoms reconfigure themselves over 13.8 billion years into your sofa. This is like, so this light here that you're seeing eventually becomes the matter that we deal with every day. Talk about why science matters. Like, this is the light that becomes the matter that we live with. Okay. And we see that happen. So what I'm going to do here is show you how, as that, remember, this was a very hot time in the universe. So as that cools, what we see happening in the background of that image is that it all kind of sort of coalesces into these tendrils of what we call the large scale or mega scale structure of the universe. Actually, as I'm looking at that, I'm realizing that's not the image. That is actually the brain scan of a rat. I always use the wrong image, but you might see why, because this is actually what it looks like. The point there is that neural networks look a lot like the large scale structure of the universe. Be that as it may, I'm not trying to make meaning there. I'm just trying to show that there's deep symmetries and that are really interesting. So this is what we call the mega scale structure of the universe. And as this evolves, and I'll let this is a simulation, an accurate, scientifically evidence-based simulation of how that large scale structure of the universe coalesces into these tendrils. And then you'll start to see, galaxies forming, galaxy clusters. I'm sure there's lots of globular clusters in there as well. But what you're seeing here is the evolution of the night sky as we would know it. So if you could go out tonight and see the night sky, you'd see this. But what this actually is, again, is the evolution of that cosmic microwave background radiation. This is what the night sky that you could see tonight evolved from. Okay. It's kind of a blueprint. It's kind of a blueprint of the night sky. But I want to go back to what I said earlier about what we're actually looking at. Again, we're trying to derive meaning, right? So this is a picture taken in microwave light. The differences in color represent differences in temperature or differences in energy, the vibrational energy. If there hadn't been those differences in temperature, in other words, if this had been a completely uniform gray as opposed to, had these ripples, had these splotches, there would have been nothing happening, because one part of the cosmos would have been precisely the same temperature as the other part of the cosmos, and there would have been no impulse for anything to change. There would have been no gradient. If there was no gradient, that means there's no relationship. This is really profound, because what it's actually saying is that all the complexity of the universe, all the complexity of this world that we inhabit, comes to us, comes into existence through ecological dynamics. My point is this: why science matters. In this case, what this science is telling us is that the cosmos that we live in is an ecosystem. The cosmos is ecological. In other words, relationships are everything. I mean, think about that. What matters? What matters to you? What matters to us are relationships, the relationships that we are in. That's scientifically accurate to say right back to the beginning of the cosmos. We live in a cosmos where relationships matter, even before there was anybody to talk about our relationships. Before the first breakup, relationships mattered. We live in a cosmos where relationships matter, and that's why they still matter to us today. Okay, next step or next stop on this journey through the cosmos, I decided we would look at this period here, which is probably about 4.7 billion years ago, which is called an era where the protoplanetary disk of the solar system formed. Okay, so I'm skipping a lot of science here, but we're going to jump right into this moment here. So this is an artist's depiction of our star, the sun, And what we're seeing here, which is really cool, are these rings. Let's start the motion here. So what we see is this thing spinning through laws of the conservation of angular momentum. And if you look carefully, you'll start to see these little celestial bodies start to appear in the little alleys, in those clearing out alleys. And what's happening is that you've got all these dynamics at play. You've got the photons streaming off of this star, creating what's called the solar wind. And that's pushing any vapor and any gases away. It's pushing it out into the outer. You can kind of see the shadows behind these planets. And so what's happening here is that you've got the solar wind pushing gases and everything out into the outer reaches of the solar system. And in close, things get really dry because the water vapor gets pushed out along with all the other gases. Now, this makes sense that the inner planets then would be kind of rocky and dry. And that's what we see. Mercury and Mars, those are really rocky planets. They're dry. And then as you get further out, further and further, you start to see the gaseous giants. So you get, Jupiter and Saturn and these gaseous planets. So there's this complex ecological dynamics, again, relationships happening between these bodies and their star. And what's profound here is that little third one, what should probably be a rocky planet, which should probably be pretty dry because it's so close to the sun, it ends up having some special treatment, some odd scenario, some odd constellation of factors made it so that it had water. Like it's a little bit inexplicable that our planet would have so much water. And the point here is just that, to know that astronomers and planetary physicists and things have been contemplating and modeling and wondering about how could it be? How could this planet be so improbable that water would exist in all three phases? It's kind of mind-blowing, the improbability of circumstances that have to align for a planet like ours to come into existence. It's just such an oddball. Now, of course, we don't know that we're the only planet with water, or we can almost say for certain we're not. And but we're the only planet we know of with life. And so, but now we've launched this new satellite, the James Webb Space Telescope, which is actually the really fascinating thing here is that before now, all we've really had by way of trying to explain how our planet could have these special circumstances where it has all this abundance of water were through models. And the models never really were satisfying. But now, because of the James Webb Space Telescope, we're actually starting to be able to actually visibly see this thing. So I'm going to just let this visualization play, because we've aimed this satellite now at this one of these protoplanetary disks, PDS-70, and we're starting to analyze what we see. And what we are starting to see is that we can, because it's an infrared telescope, it uses infrared light, we can begin to see how water is distributed in these protoplanetary disks. And so we're starting to get this confirmation through this detailed study of spectrometry within these planetary systems that it makes sense. So I just want to stop now and just start to think about, like, well, why does this matter? Like, so why does science matter in this case? Well, I think Carl Sagan said it best when he said, the Earth is the only world known so far to harbor life. He goes on to say, there is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and to cherish the pale blue dot, the only home we've ever known. What he's encountering there is the sheer fascination at the just vast improbability of a planet like Earth, and all of the science that we are now compiling to tell this history of the Earth and the story of the Earth's formation. It all comes into coherence. All the models now make better sense, and we can see clearer and clearer every day just how rare and precious and unique and precarious our position is. And so what is this saying? And we use this new telescope to look out, and we're starting to see lots of planets. We're starting to see lots of potential planets that could harbor life, but nothing yet, and it just goes to show that, look, we are either the only form of life in the cosmos, in which case, man, we represent the only life in the cosmos, or there is life in the cosmos, in which case there's someone to represent too, in which case we represent the Earth. Either way, all of this science matters. Now, if anybody's interested, you may have seen this image before or not, but the pale blue dot that Carl Sagan is referring to, if you look closely, just above the 4 and a little bit off to the right there, that's the dot. That's the Earth suspended in a beam of light that he's talking about. So this is just another instance where astronomy and chemistry and geology, we can derive meaning from these things. Remember, that's what we're doing. We're saying, is there meaning to be derived from something as objective as science? Ask Carl Sagan. All right, next stop on this journey through the cosmos, we are going to get on the Earth. Earth has been doing its thing for 500 million years now, and it's probably about 2.6 billion years on the planet. There's since the formation of, hold on, let me get that straight. 2.6 billion years ago, so it's about 2 billion years into the history of the Earth. There's no life. There's no, nothing has colonized the land. Basically, you've got a planet of geysers, and this is after what's called the late heavy bombardment, when there was still a lot of asteroids crashing into the Earth. And there's a lot of geothermal activity, and there's the water. There's that water. A lot of it was in the rocks and came out, through cycles of melting. And a lot of this water probably came back in on comets and asteroids and planetesimals that smashed into us. But anyway, we've got this planet that is rich with water. It's got these high thermal gradients where magma is heating up this water. There's lots of things dissolved in this water, minerals and salts and strange organic compounds, not meaning that they were produced by life, but they're complex. They're complex molecules, oily things, greasy things, clay-like things, lots of little molecules that are dissolved and moving around in these puddles on the surface of the Earth. One of the little molecules, this little guy, strange little thing. This is not alive. Okay, this is not a living thing. It's called a phospholipid. The reason it's called that is because one end, it's got phosphorus. It's got a phosphate or a phosphorus. The other end is a lipid. It's kind of waxy. It's kind of greasy. So it's the little legs with the ends that are long. There's long chains of molecules there. Those are the ones that are waxy. So they don't like water. We call them hydrophobic. So that end of the molecule does not like water. Hydrophobic. The other end, the end with the phosphorus of this phospholipid molecule, loves water. So you've got this molecule that just by chance of phosphos and lipids coming into relationship with each other, you've got one end that doesn't like water and one end that does. If you let these molecules just self-organize, come together, look what they do. They come in, they organize themselves into lines, then they organize themselves into sheets, and then these sheets come together in a way where the hydrophobic layer can keep itself happy away from the water by being insulated, where the hydrophilic end can stay in contact with the water that it's dissolved in. So it's this like elegant solution that has been created. Now you've got these layers, these are flexible layers, and they're moving around in the water. But there's there's no engineers yet. There's an intelligence operating here in this phospholipid bilayer. That's what this is called, where it's figured out a way to keep itself intact. It's figured out a way to take this polarity that it has inherent in its form and put it into use to create a new form that keeps it intact, that brings a kind of coherence, that brings a kind of a durability or a resilience to this new structure. Now, here's the cool thing. I'm going to let this play again. And what you see is what happens is you take this sheet, this purely organic but not living sheet. This is just a different depiction of it. What can happen sometimes when these things are free to float around in the water is you get these two ends and they're just sort of flopping around, and just given enough time and enough chance, sometimes two of these ends can find each other like that. When that happens, all of a sudden in the universe, for the first time, you've got this entity where there's an inside and an outside. Okay, this is how a purely non-living thing starts to look like life. So life doesn't just happen overnight. You don't go from non-life to life like that. It happens slowly, like this, things like this that are not really life. Now, when this happens, remember, this is like an oily film, right? It has miscibility. In other words, certain things, I'm not going to get too much into science, but it turns out that this feature, this form of this thing, it has this exquisite capacity to let certain things through and not other things. It's not a wall that protects the inside. Instead, it's a membrane. It's a surface of contact that selectively lets things go in and out. It's not a wall of protection. It's a surface of contact. Okay, but it's almost an intelligent surface of contact. It can discern things. Okay, my point is that this feature, this thing that we're looking at now, goes on to be one of the most essential structures of all living things on Earth. Every cell in your body and your dog or cat is bound by this kind of a membrane. Same exact membrane allows all the functions of living things are because of this membrane that happened likely in some little pond, some little puddle, where this kind of, given enough time and chance, this kind of thing can happen. And it goes on to become, hey, not only that, what we're finding out now is just how important this membrane is to communication between living organisms. Organisms communicate all kinds of like molecules and are transferred between living organisms through vesicles made of these kinds of membranes. My point is that this is why science matters. Remember, that's a polar molecule. It's got a side that hates water and a side that loves water. But somehow the intelligence of nature figured out a way to turn that polarity into something that would then become essential to all life on Earth. This is how science matters. You can learn how to get along, or at least get some ideas on how to get along in ways that we don't expect when we start really thinking about science in this way. All right, on to stop 4. So this one here is okay. This one's really crazy too. So life has been chugging along now. We've taken that membrane, that phospholipid membrane, and unicellular life gets established in that. And then what happens soon after that? Well, this is an image of the Earth. Well, it's obviously not, but the point is, like, this is what we might think of that the Earth would have looked like about 2.6 billion years ago. But in actuality, it probably looked something more like this. It probably would have had more of a sort of a grayish, reddish, orangey tinge to it. The oceans would have been a completely different color, probably more like maybe green or reddish. not rust red, but green. And anyway, so this is sort of an artist's depiction of what the Earth would have looked like back then. Now, don't get me wrong, this is a thriving place. Okay, it's just thriving with life that is fine-tuned to this kind of an atmosphere. And when I say that, I mean this is not the atmosphere that we have today. This is an atmosphere that's got lots of sulfur and ammonia gas, and the organisms that are metabolizing here, they're doing a kind of photosynthesis, but it's not the kind that we do today. In fact, they're using things like sulfur instead of water to do their metabolic work. So, but this is a thriving world here. It's just a world that we wouldn't be able to thrive in. We would be suffocated here because there's no oxygen. There's no oxygen in this atmosphere 2.6 billion years ago. So what ends up happening, though, is that one little innovative upstart bacterial organism in the oceans figures out a way to capture photons, to use the hydrogen that's in water and sunlight to combine it, use the, excite some electrons and to create some sugars, some carbon hydrogen bonds to store energy and give off some oxygen in the process. This is oxygen photosynthesis. Oxygenic photosynthesis has now happened in the oceans. Life has figured out a way to metabolize sunlight and with oxygen as a byproduct. You do this for long enough, you release this oxygen gas into the atmosphere, and it goes from that gray whatever into this thing that we sort of recognize as comfortable and full of air that we can breathe. And then it goes from this eventually into the verdant, living, oxygen-rich atmosphere that we all know and love. Okay, so this event that I'm talking about here, where these early photosynthetic organisms completely changed the composition of the early atmosphere from a reducing one into an oxygenating one, is called the Great Oxygen Crisis. There's another crisis that I've been talking about, the meta crisis. Well, this was a crisis. This was a real meta crisis too. The point here is that, well, one of the points we can take home from this is that, well, I'm going to go back here to this shot for a second. The point here is that this has happened before. There was a time when an organism on this planet figured out a way to do something, and in the process of prospering from that invention, changed the composition of the atmosphere in a profound and dramatic and irreversible way. It's happened before. So we shouldn't be so hard on ourselves, but we're doing it now. Like, it's happening again, right? Like, we got to come to terms with that. This is why science matters, because it helps us come to terms with the fact that it has happened before and it's happening now. What are we going to do about it? That's the question. Can we do anything about it is the question. And if we can't do anything about it, what does the post world look like? Like, I don't know. Ask the archaea bacteria. Ask the anaerobic bacteria that are now relegated to live in the deep ocean where there's no oxygen, where they can still thrive down there, but they can't live in the oxygen-rich world that we inhabit. Who's going to inhabit the worlds that we're creating now? It's a good question. Anyway, I think the man who put it best, the meaning that comes out of this is this: no man ever steps in the same river twice, for it's not the same river and he's not the same man. The point here is that there is nothing permanent except change. And I think this is a kind of meaning that we can derive when we know this story of science, the story that science is telling us about the world. All right, here's our last stop on the cosmic journey here. It's covering a lot of ground. That early photosynthetic life ends up evolving into multicellularity. Lots of things happen. The Cambrian explosion happens. We see this real adaptive radiation of life, all kinds of new life forms, all kinds of setbacks, ice ages, asteroid impacts, all kinds of things happen. But eventually, a little mammalian shrew-like creature gets a chance when the dinosaurs go extinct, and that creature ends up evolving into a warm-blooded, furry creature. And that's where we are now. So we pick up the story about 7 million years ago. This is a Sahelanthropus species living somewhere, probably in Central Africa. And I like to imagine that this species evolves, and this is an Australopithecine, and these species are moving through all the different habitats of Africa, encountering all these species, all these different animals and habitats. And we're talking about hundreds of million, well, at least 200 million years of evolution of doing this. And we have a lot of the stories that happened are starting to be found in these footprints, and you can reconstruct events, and you can see them moving through all these different habitats and adapting. And I like to think that one day, perhaps, they were moving along, and they had these seed pods, and one of them saw some rocks and decided that it would be a good idea to hit two rocks together in order to create a sharp edge so that they could open up the seed pods. And voila, they had stone tools were invented. And what we're seeing here, really, if you think about it, is the emergence of storytelling capacity, which I mentioned early in early hominids. But this kind of stone tool ended up evolving into this one. I don't know if you can feel the difference, but I sure can. When I look at this and then I feel this, it's a big difference. Whatever hominid, probably Homo habilis, who made this one, this is whoever made this hand axe, really had a fine appreciation for symmetry. This one here is another, it's called a Mousterian hand tool. It's made by this technique called lavawa, where you hit it in a sequence of chips, and you create a surface, and then with the final blow, you create the piece that you're looking for. It requires quite a complex cognitive sequence in order to pull something like this off. If you try it, you'll see what I mean. But really what we're talking about here is the emergence of metaphor, because in order to be able to see the tool that you want in the base tool that you have, to be able to see one thing in terms of another, is the capacity for metaphor. And what we see is that these early hominids, they leave Africa with these capacities of storytelling, aesthetic appreciation, and metaphor, and they encounter things like this in their environment, and then suddenly they're creating things like this. They're representing the creatures that they encounter and the world that they live in through this new symbolic capacity in the way that they manipulate stones and wood and ivory. And so that when they encounter things like this, elk swimming across this lake, they carve things like this, and that just the detail and the amount of knowledge that it's required to do this, it just reveals the intimacy by which these people lived with their environments. And when they see things like this, they represent it in this sort of semi-abstract way in the cave wall, and they see this, and then this is a single bone disc, and it has an image on either side, and when you put it together in a certain way on a piece of leather and you spin it in this way, suddenly you've animated this antelope to do this thing called stotting. It's like, this is like the first animated movie. My point is this, that the earth is teaching us. You see what's happening here, that this species, this hominid species, is leaving Africa, and as it moves through all the different habitats of this planet, it's taught how to do things. So it moves through jungles and across savannas and near estuaries and through swamps and near mountains and even across oceans. Eventually, it ends up doing metaphor. And so what we have is cavemen eventually doing Shakespeare. The stones have taught us how to do Shakespeare. And so this is it. Like Shakespeare says, "And this our life exempt from public haunt finds tongues and trees, books in the running brooks, sermons in stone, and good in everything." My point here is that what we see here is paleoanthropology, the study of how how human beings came to be able to fashion stone tools and the cognitive capacities that it requires to do that, eventually becomes art. That's why science matters, because art. I was originally going to call this talk Why Art Matters. I ended up calling it Why Science Matters, but you end up at the same place. Who says that? Why science matters? Because art. When you understand enough science, you understand why art matters. And then telling the story of science artistically is you understand why science matters. This is all of this, again, is really just an exercise in how do we derive meaning from this story. So that's what we've done here. That's what I've done, is to just take this story and go along and just stop briefly at these different stops along the way until eventually we come out here, and then lo and behold, we find meaning. That's the idea here, the question was, why does science matter? Well, for all the reasons that I just spelled out. If you understand and you really look at the scientific story of the universe, you realize when science matters, this is what you get. Your values tend to align with the ecological constraints. It's just that simple. When science matters, there are no unassailable dogmas. Okay, everybody's sacred cow gets gored. Everything's provisional and adaptable. When science matters, it allows for accessing a fascinating and inexhaustible fount of meaning. When science matters, it links us to an unfolding story of awe and the human presence in the cosmos. When science matters, it is convivial. In other words, that it tends to cultivate a sense of embedded participation with life. When science matters, what we reveal is how the differentiation is contextualized by continuity. We'll have to just let that sink in, but think about all those stories that I talked about where something was differentiating, but it wasn't differentiating in isolation from what was before and what was after. It was all along a continuum. It's differentiation along a continuum. And when science matters, it links meaning to knowledge and knowledge to wisdom. Okay, so back to Vervaeke. We are in a meaning crisis. Are you kidding me? This is my question. I love John, but I'm just saying, like, how can we be in a meaning crisis when we have this story of the universe available to us through science? And somehow we've come to believe that we are in a meaning crisis, that the meta crisis is a meaning crisis. And so my point here, my proposal, is that no longer should science be discounted or excluded as a source of meaning. They should all be. And just to bring this back home and to put it into the context of tonight's talk, how about this quote? I'm blown away by this. The greatest benefit from the study of science is that it lifts you out of and above the littleness of daily trials. We learn to live in the universe as a part of it. We cannot separate ourselves from it. Our every act connects us with it. Our every act affects the whole. Can you imagine who would have said that? It's, of course, she understood the universe in her Victorian way. But I can just imagine if she were alive today, she would precisely know what it is that I'm proposing tonight. And I think that's why I'm here tonight. So that's it for my talk. That's why science matters. I'm happy to stick around and take any questions or anything anybody wants to talk about. I hope that was enjoyable, folks. And if anybody wants to learn more, you can just check me out at oika.com, 7 o'clock. So that's 1 hour on the nose.
You crushed it. Thanks. Dr. Blundell, thank you so much for your wonderful presentation on why science matters. And I'm sure that most of us are bursting at the seams with questions. I would like to share with the audience this evening that if you have any questions that you'd like to pose to Dr. Blundell, you can go ahead and type that in the Q&A box, or if you raise your hand and I see your hand raised, I can give you speaking permission through Zoom, if that appeases you guys this evening. And while we wait for people's questions to stew and bubble, I guess I'd like to unpack a few things. But first, I'll start with, why did you opt to not include AI in your chart?
I would have included it. It's what's interesting is that that's the World Economic Forum. They didn't include it.
Mm-hmm.
I definitely would have included it. I think it's the most important issue of our time. I think it's yeah. So I mean, and while we're on the subject, I happen to think that this thing that I'm proposing here, how we reconnect with the deep source of nature's intelligence, is what we're going to find is that is the most appropriate response to the challenges that the AI is going to present us with. If you really think about what's going on with the AI, like the first iteration of AI was the algorithms that tech companies like Facebook subjected us to, right? It was like this curation about how they made decisions about what information made it to individuals. That's curation. That's them deciding through algorithmic means what information that we were going to be exposed to. The next wave of it, which is what we're feeling now, is an AI that actually generates that content. It doesn't just curate the content, it creates the content and delivers it. And then there's a third one, which is where it just goes and does it. It basically takes over. It controls. It goes from curation to creation to control. And that sequence of events is a hard one to come up with appropriate responses to. My proposal is that human beings reconnecting with that story of the cosmos that I've been telling, when you start to see the intelligence that's operating there, that's not in us, but in the world. That's why I tell that story of humans and how there are books out there, I won't name names, but that talk about how the human species is just this incredible species that shows up with all these skills to adapt and extract and exploit its environment. That is an absolutely asinine way to see the world. What I'm trying to say with that earthling theory thing that I was saying is that we didn't just show up with those capacities. The world taught us those capacities. It's the earth that's teaching us those intelligences through relationship. The same relationship that's inherent in the whole of the cosmos is now expressing itself through the relationships between humans and habitats. Habitats are endowing us with the intelligences that we somehow have come to think are ours alone. They're not ours. They're the way the earth has been teaching us. My point is this, and this gets back to the AI. It's that understanding of who we are and the depth and the source and where our intelligence comes from that is going to be the best and a most appropriate response to how we deal with the artificial intelligence that's being imposed on us. That's what I'm trying to say. And I know that might sound controversial, but when you really do get a sense for the continuity of this story that I've been telling and how the intelligence moves through it and is now embedded within us, you realize that that's going to be the way that we best respond to and manage and work with what we call artificial intelligence. Sorry if that went off too far with your question, but I would have included AI in there. And I think that we're going to have to start including it in a lot more conversations.
Well, I guess my follow-up question would be, and it may be a little vague, is how would you correlate technology or the climate change experience as a result of technology to the human climate change? So the physical climate change that we're seeing in the world and the human climate change as a result of technology and artificial intelligence? Or is there not a correlation there, in your opinion? Or parallel, perhaps?
Can you ask the question again?
Mm-hmm. So I just got to thinking about artificial intelligence and how it's changed the human climate. and it
You mean
also
the actual climate?
so the human climate, like me as a human as a whole, how does technology impact and change my life? How has it automated a lot of
Okay,
processes in our
okay,
lives? How we've become overly dependent in some areas on
okay,
technology? And
okay.
I'm just curious as to your thoughts on how it could parallel potentially with the actual climate change that we experience. And there might not be a parallel, just something I just thought of as you shared.
I think there are. I think there are, and they're scary
Mm-hmm.
because look what happened last time the climate changed like that. The actual climate. It's irreversible. And the things that used to thrive are now, you know, I'm not making a judgment, but they're relegated to a lot less habitats. Um, you can make a lot of analogies there, but they're starting to sound like science fiction. I'm not going to do that, but I'm just saying, yeah. I mean, you could make a lot of you could make a lot of speculative scenarios. Um, but I will say this: that whatever the scenario plays out, I know it will be better if whatever we do is aligned with the intelligence of nature versus somehow not.
Mm-hmm.
Any culture or society or civilization that thinks it's going to survive in the cosmos by decoupling its intelligence from nature is a short-lived endeavor. Because look, you want to go to the stars are nature too. You know what I mean? And so to decouple the ethos of your civilization from nature, it just doesn't sound like a smart way to go. And so whatever we do, I think will that's not to say, again, I'm not proposing that we go back to the Paleolithic or anything like that. I'm just saying that working with being in alliance with nature as opposed to working against it is a no-brainer. And the way to do that, I think, is to just simply know the story and be able to tell the story in meaningful ways. And that's what I'm trying to do with this, tell that story in meaningful ways. So I just stopped in on 5 different sciences: astronomy, chemistry, geology, biology, and paleoanthropology. They've all got meaning embedded within them. We don't use it as a source of meaning. We use all these other things that were on that list.
So would you say that we are disconnected from nature's language as a society and as a populace at large?
At large, I would say that, yeah. I think, and the evidence for that is the super wicked problem. It's the meta crisis. That is that I think if you need evidence for that, I wouldn't say that anyone in particular is that way, but collectively, obviously we are. Otherwise, we wouldn't be staring at off the edge of the cliff as we are now. Mm-hmm. I think that's how we back away from the cliff.
So how do you propose we gain more buy-in on changing the human climate or realigning the human climate?
I think we, first of all, we need to call on artists in this. Art's an incredibly powerful and sidelined force at this point. And so we need to, that's powerful. And also just be willing to reinterpret the science that we know and not maintain this allergy of deriving meaning from science. I know the tension there. I know the conflict because I'm trained in the sciences and I work in the world and I work with meaning generation. I know the difference between knowledge production and meaning production. And I just think that it needs to be less of an antagonistic relationship. I know that it needs to do good science, and I think that's incredibly important. But I just think that we need to be more open to being able to make meaning of science. Carl Sagan did it. We need more Carl Sagans. That's what I mean.
So where do we start? Not in college.
Well, it's a good question. It's hard to do it through the educational system because it's entrenched and because it's hard to change. As you know, it's very hard to change. Even though it wants to change, it's hard to change. I think culture. That's why I think artists are an incredibly important part, because you can change culture still. And it's hard though, especially in the face of curated content. There's a lot of incentivization behind the way things are done. And so I don't know. All I know is how to do. All I know how to do is to tell stories and get excited about science, and be willing to let other people see it.
I wouldn't say that that's all you know how to do. You do that quite well.
Okay. Okay. Thanks.
And at home, just as a reminder, if you have any questions for Dr. Blundell that you'd like to pop in the Q&A chat box, please go ahead and do so that I don't commandeer this entire conversation. So we have multiple viewpoints or questions. In the meantime, can you further unpack the statement, the values align with the ecological constraints? That one up to my attention.
Well, the first part of that is that when science matters, then the values that we derive from science, which is that's what this was an exercise in doing, are already aligned to ecological constraints, because they are coming from ecological stories. They're not invented stories. They're coming from observed phenomena of nature, which place, so they will be stories constrained. When I say constrained, that's not a negative thing. It's that they're grounded, that they are linked to a much larger source of intelligence and wisdom than mere fantasy. They're grounded in nature's intelligence. That's what I mean. And so if they are coming from nature, if they're aligned with nature, then they're going to have embedded within them ecological dynamics already. That's what I'm trying to say, that they will be implicitly, organically ecological when they come from ecological systems. And I don't just mean, like nature, like the way we think of it. I mean the cosmos. The whole of the cosmos is an ecosystem. That's what the cosmic microwave background is showing us. It's like, whoa, it started as an ecosystem of light, and now it's an ecosystem of trees and birds and everything else, and people.
Where do we go next? Intentionally vague.
Oh, big? You mean big?
No, vague. I'm being
intentionally vague. I think well, for me, I just keep doing what I'm doing and keep trying to get this understood, and just keep trying that, and hopefully if it works, it shifts the consciousness in some small way, and someone else shifts it in a small way, and then that the collective shift at some point is discernible. And who knows, and it may or may not be discernible in any particular lifetime, but the good news is that it sure is beautiful and sure is fascinating and meaningful in the process. And so even if the shift is not discernible in any particular lifetime, you get to participate in something. You get to, that's very rewarding.
Amazing. I hate to ask another question, but I'm going to.
Okay.
Given your intimacy with the life cycle of our planet, and correct me if that's an incorrect statement, but I find you to be very closely familiar with it.
Yeah, it feels that way.
Do you feel as though that there is hope for us to realign and recalibrate, so to say, before the
Ah,
effects or the impacts
yeah.
are too
I'm
much?
I'm very hopeful. And you know why? Because when you are intimate with it and you see how it works, when you see
Mhm,
how powerful this ally is,
mhm,
it's so fascinating because, man, like if you it's just that it's such a big problem, right? We're in
mhm,
such we have such a big, complex, difficult problem before us. It makes you think that, man, the solution must be big and difficult.
mhm,
It must require a lot of suffering and a lot of sacrifice in order to solve this problem. But here's the thing: once you have that intimacy that you're talking about, once you see how it works, you
mhm,
realize, oh, it's not hard. It doesn't take a lot of suffering. This isn't about sacrifice and compromise. It's about getting in touch with something that's really beautiful
mhm,
and fulfilling and like hopeful, and like suddenly, and then once that tiny little shift happens, it does the work. It,
mhm,
like you just let nature's intelligence, because that's what it does. you know the healing doesn't require a lot of, it just requires allowing oneself to feel that sense of intimacy, that sense of belonging, and then suddenly things start to real that sense that the healing power of nature's intelligence is so powerful that we don't know how to even acknowledge it,
mhm.
right? That's why I'm hopeful, because as long as, if we just like take the hands off the wheel a little bit, it suddenly you feel the power of that intelligence go to work. So it's not about hard sacrifice and work and pain and suffering and guilt and shame. It's about allowing oneself to feel close to that sense of creative beauty and all of that. I know that all sounds very naive, but it's not.
Mhm.
So that's why I'm hopeful.
I appreciate that. That gives me hope,
Yeah.
genuinely.
Yeah.
I would say, do you envision AI and technology as an entire lumped concept? Being which side of the scale do you imagine it tips us toward realigning or just further catapulting ourselves into a deeper trench per se that we need to climb out of?
Well, it depends. I'm not afraid of the technology. I'm afraid of who wields it and
Mhm.
why. That
Okay.
um and so whatever it is and whatever the technology does,
Mhm.
it will reflect us. That's why we got to get ourselves straightened out.
Mhm.
We have to improve our inner climate.
Right.
And then I'm not worried about the AI at that point.
Mhm.
You know, it will reflect whatever our inner climate is.
Right.
So yeah, that I guess that's my answer to that.
No, I appreciate that
Yeah.
answer.
Yeah.
It aligns with kind of where I fall on
Mm.
that scale. Because I do think if we, here is not the word I'd like to use, but I'm going to stick with recalibrate. If we're able to recalibrate as a populace, as a human
I
climate,
like the idea. I like the idea of just
yeah,
remembering,
yeah,
in like remembering and then remembering,
hmm,
and it does the rest. Nature does the rest.
and how does the James Webb Space Telescope images, how do they drive your storytelling or your understanding of the history of the Earth?
The funny thing is, I haven't had a chance to really spend too much time with the images yet. I'm
Hmm.
looking forward to that, but I'm really excited about the way that it is giving us visual confirmation of things, that we otherwise only had modeling for in the past. That's really fascinating. Um, I just think that's the other thing too, is that it's subtle, but what ends up happening is that the data that we're collecting, it ends up conforming or slightly not conforming to what we already know, not to what we already know, but it fits in, it affirms in a way, and that is really powerful, because it's another line of evidence that either, it's slightly adjusted, but nothing's showing up that's so out of line with our models and our theories. I understand, like, there's like the threat or the danger of instrumentalism, which is like you only design instruments to see the theories that you can, that it confirms those theories because you design the instrument to see things that confirm it. I know about that danger, but the point is just that what it is seeing and the way that it is confirming our theories about things in a way that is consistent with them being accurate.
Mm-hmm.
I know that sounds very sounds like I'm hedging. What I'm saying is that the fact that that's good. Like that means that we have a pretty accurate picture of cosmic evolution when the observed data that we're getting with the best instruments doesn't fall perfectly in line, but well in line enough so that we can adjust without having to throw out the whole theory.
And I may oversimplify this, but for me, it alludes to our wisdom being inherently connected with the knowledge that we've gained.
Ooh, I like that. Yeah. That's a good definition of wisdom, that it's already coherent, that it's cogent with what we know.
Right. It's a knowing that we already have. The knowledge perhaps gives us a tool or a means to access the wisdom.
Yeah, but not perfect, because it's not like, it's like, it's not like perfectly right, because that would worry me if it were. It would be like, yeah, that's a little too good to be true.
Right. Be scary. I would agree.
Yeah.
We have
it's great to see the accretionary disk stuff coming in too. Just I love that stuff.
We have a comment from a guest, Kathleen, who says, "Hi, this was absolutely wonderful. I do not have any type of science background, but the entire presentation resonated with me. I would love to rewatch so that I can fully absorb all of what you touched on." She said, "Thank you," with a smiley face.
Thank you too. Thank you.
Any parting thoughts you'd like to share with us?
No, I don't think so. I think that was pretty good. I just really appreciate the opportunity to, have come here and explore this stuff and develop these ideas and start telling these stories. And it's a perfect place to do it. I'm constantly amazed at how Mariah Mitchell knew this stuff in her own way, and in her own constrained way, constrained by her culture of her time and the science of her time. I think should be right here with us. I think she would have been right in, and I'm just so grateful to know that there is an organization that's positioned to be able to appreciate this. There's not many. I can't think of any others who have held on to that legacy of hers in a way that can now find expression today. That it's almost like it has survived modernism, like that. Like this organization, Mariah Mitchell, happened to come of age in a time when Enlightenment science was kind of reaching its apex, and then with ever since then, after the Victorian era, we ended up, after the Industrial Revolution and all that, we got very philosophical, and then we got into postmodernism, and now we're starting to come out the other side of that. And here is this organization, and this institution really that has survived that. And now perhaps we can start to, keep the science alive in a way that is, that can be really meaningful. So I'm hopeful about that. It's really great to see that.
I like to think in my heart that her connection to nature, her connection to the earth in that time, it's her wisdom. It's her knowing, and her knowing is what drove her to seek more knowledge and to marry those two things together in real time. So
and the nature that she would have encountered, it's those intelligences, those cues that nature gives, especially the ones that we experience here on these trails and in these forests and on these beaches, are the same ones that she would have, and they're universal. So whatever cues she got, we get, and so we're drinking from the same well, and I think that's important. That matters.
I would agree. It's a perfect note to close on.
All right. Thanks again,
If you'd like to share with our audience any upcoming things on the horizon for you with us.
Sure. Yeah, we got a I don't know if you remember, we did a really cool show here, an Oika art show at the gallery here on 33. One of the artists, Rita Leduc, and I have a really cool new exhibition starting up at the Museum of the White Mountains in New Hampshire, and we're bringing these ideas and this whole idea of making meaning that this lecture was about, this idea of making meaning with nature, we're bringing to the White Mountains. And so we've been, for the last 2 years, we've been going up to this experimental forest up there, and we've been going into the forest and making meaning, and this much the same way that Mariah Mitchell and I did here this summer. Not me and Mariah Mitchell, but the way that Mariah Mitchell would have and the way that I have this summer. We have an exhibition. It's called Making Meaning with the White Mountains. It's at the Museum of the White Mountains, which is associated with Plymouth State University. You can get to that through my website, oika.com. You can pretty much you can learn about all the different things we've got going on at oika.com. But that's an upcoming exciting thing that we've got going on.
And your next program with us?
Oh yeah, rocks. We're doing a rock talk this Friday, and then the following Saturday for the next 2 weeks. So it's gonna be really cool. Gonna talk about the geology of Nantucket, which really is talking about the geology of the Eastern Seaboard, which isn't really cool when you think about when you put the geology of Nantucket in the context of the geology of New England and then the last 500 million years of geology on this planet. And then the following day, we're going to do a walk on a place I haven't figured out yet, but we're going to do a walk where I teach you how to think like a geologist, and we're going to go out and look at all the different stones and see, actual rocks from Nantucket that tell the story that I told in the lecture the night before.
Amazing. Well, we're definitely excited for your upcoming programs, and I'm very hopeful that I can catch you and Rita in New Hampshire.
Be great to see you.
I love the White Mountains, so.
Me too.
Well, Dr. Blundell, Rich, it's such an honor always to have these conversations with you. I feel like I always unpack something new of my own wisdom and my own knowing that causes me or results in me forcing myself to seek more knowledge. So I'm just always so grateful and appreciative of the conversations that you steward. And it's been our absolute honor and privilege to host you for our Science Speaker Series on September 13th, 2023. And we hope to hear more from you soon.
Thank you.
Thank you, everyone, for joining us this evening. Thank you to Bank of America, our lead sponsor, Cisco Brewers and the White Elephant Hotels and Resorts of Nantucket and Palm Beach. And I wish everyone a happy Wednesday evening. Go enjoy your dinner, and I will see you guys soon. Thank you, everyone.
Okay, thanks. I know that was kind of out there, but it is what it is.
No, you're great.
Okay.
And let me stop recording.
Good idea.
And people are exiting at the same time.
Okay.